Once again, Liberty, thank you very much for this opportunity to do this show at home. We really appreciate it. But let's just quickly go back to GIS. So what is GIS? We looked at the different components, geographical information system. So we use hardware, like for instance, computers, printers, software, different types of programs. Okay, we use people, analysts, people who capture the data. Okay, we use programming. So what does it do? It solves problems for us and help us with planning. Okay, now coming back, if we look just before the break, we look at spatial objects. Okay, what are spatial objects? It can be buildings. It can be like a massive building as you see in town, like a double-story building. And how will it? It's usually going to be a little dot. Okay, and then we have rivers, for example. It can be many things, spatial objects. It can be a river, it can be a road, it can be a railway. And if you look at the shape of it, what's the shape of it going to be? It's going to be linear in shape. And then we have cultivated land. Now keep in mind, this is just some examples of spatial objects. It might be cultivated land, it might be a golf course, it might be a recreational field, it might be a soccer field, or it might even be an excavation like a mine. So all of these can be identified as an area, a polygon. Now, to be able to see these different spatial objects, we use resolution. Now, grade 12, the best possible way to use resolution as an example for you is just by looking at your smartphone. Okay, so let's say, for instance, you want to take a selfie. Which phone are you going to use? The one with the highest resolution. Okay, highest pixel quantity. Okay, so that determines on remote sensing. We get high and low resolution. But let's just quickly define resolution. And what is that? Let's write it down. The ability of a remote sensing sensor to create a sharp and clear image. Coming back, you and your bunch of mates want to take photos with your smartphone. Which smartphone use? You're going to use the one with the highest pixels. Okay, because what's going to happen to the image? It's going to be much more clear. Even do yourself a favor. If you look at your camera and you're taking the photo, just zoom in onto it and you will actually see the pixels, little bits of blocks. It looks like blocks. Okay, and we're going to come to this a little bit later when we discuss vector data and such. But let's just concentrate on resolution. It's the ability of a remote sensing sensor to create a sharp and clear image. So remote sensing is that satellite that captures a beautiful image. And what does it catches? It catches, if we look at back, objects such as buildings, rivers, cultivated lands, any object. But if we look at the resolution, now we can distinguish between two different types of resolutions. And let's just quickly have a look at it. I'm going to use a different color pen. Okay, we have high resolution. Just want to use it to my next page. And we got low resolution. Okay, we quickly need to differentiate between these two. Because when we look at a high resolution, that's that image just perfectly clear. Okay, you can go and ask any photograph, right? What is the most beautiful and most clear photographs? It's high resolution photographs. Okay, because they consist of more pixels. Low resolution, difficult to be able to see. So unfortunately, I don't have examples in front of you, but if you just take, let's say for instance, you take a photo of an iPhone 11, iPhone X or whatever, I don't even know where they are at the moment, but, and you take a photo of an iPhone 4, and you compare the two photos to one another. Which one's going to have the highest resolution? Probably the iPhone X or iPhone 11. I don't know where we're at. Okay, but what's the main difference between these resolutions? Many pixels. And with low, less pixels. Okay, the pixels is also very smaller. And obviously, when we look at low resolution, larger pixels. And lastly, because of the high resolution, because of the better quality of the photo, it's going to be much easier to identify the objects. Am I correct? Okay. It's not going to be blurry. We will be able to identify the building. We might be able to identify the road or the river. Okay, so what can we say over here? The objects is easily recognized. And unfortunately, with the low resolution, not easily recognized. Okay, so that's the difference between high and low resolution. Many pixels, they're much smaller, much more detail. So we can see our object, beautiful photograph. Okay, low resolution, less pixels, larger pixels, and the objects we can't recognize that easily. But let's continue, and then we come into our next topic. Not topic, but many of the questions is being asked, the different GIS data. Now, this is probably the most popular question in GIS. And I'm going to give you an example how I explain it to my learners. So easy to remember. Okay, we talk about spatial data. Let me just write it down for you, then I'll explain it to you. And we talk about attribute data. So what is spatial data? It's all geographic features or objects, both man-made, geographic features or objects, both man-made or natural. Okay, spatial data. Now, so what is spatial data? It's exactly what it is. We looked at spatial objects as an example. It's points or polygons. Okay, so for instance, it can be a river. Am I correct? Okay, it can be a building, an isolated farmstead, man-made. Am I correct? It can be cultivated land that's man-made. Okay, tricky one, but you know, waterfall. All of these are spatial data. I'm going to give you an example. For instance, a school. Your school is spatial data. Let's just quickly move to attribute data before I explain this to you. Attribute data. And let's just have a look at the definition for attribute data. It's the characteristics or description information of the geographical apologies of the object. Okay, let me quickly explain to you. So let's your school. I don't know where your school is. It might be in Cape Town. I'm going to example. Rather than another school, maybe that might take offense. But let's use Wits University. Okay. What is the geographical features of Wits University? obviously we've seen it on the map. It might be points, okay? It might be, right? As you can see, it's man-made. We looked at that because it's construction, it's infrastructure, okay? And it's the exact location. So what do we know about Wits? Witwatersrand University is situated in Johannesburg. So let's just assume the coordinates is the following: 30 degrees, 10 minutes, 15 seconds south, because we always do latitude first, remember? Longitude, 28 degrees, 15 minutes, 55 seconds east. So that's the spatial information. And how would it be represented? Probably by a point, right? Because it's infrastructure. Now coming to our attribute data, what's the characteristics of it? There's now so many. Give me some characteristics of Wits University. We have so many students, we have so many different subjects. This is the majority of people who come to study, middle income or high income people. There's so many day students on a daily basis. That's attribute data. It's characteristics about Wits University. They practice the following extramural activities: rugby, cricket, hockey, etc. Okay, what else? This is the subjects that you can choose once you want to go to Wits University, or this is what you can go and study at Wits University. Another beautiful example I can give you. Let's use a tree, for example. Okay. Now, what is a tree? Right? It's a natural feature. Okay. So let's say, for instance, it's found at this specific location. Now, what is going to be the attribute data about this tree? Okay. What type of tree is it? How old is this tree? What is the vegetation? Where is it indigenous or is it alien? Right? It gives us that information about the specific object. It might be man-made, like I've mentioned, like Wits University, or it even might be a tree. Okay, that's the difference between spatial data and attribute data. Attribute data gives us that characteristics of the spatial area. But let's continue. So we just differentiate between the two of them. Now, when we look at spatial data, once again, much confusion over there. I've just explained spatial data to you. We can differentiate between two different types of spatial data, mainly raster data, and you can look at vector data. Okay. Now, when you see the term raster, immediately, all you need to remember, think camera. Okay. When we think camera, we talked about it, we think of resolution. Am I correct? The pixels, high and low, we've discussed this. So let's do the right. And when you see raster, you identify it with pixels. And when you identify pixels, think of the image. Okay, we talked about it. Low resolution, high resolution. How do we get this information? From remote sensing. Okay, when we move over to vector data, once again, that's the spatial objects that we discussed. Okay, very importantly, like points, lines, areas. Okay, we discussed it with the spatial objects. It can be a isolated farmstead. It might be a road. It might be a cultivated land. Okay, but when you see raster, remember the pixels. Think of that little images. Okay, let's continue. Now, once we looked at the difference between the two of them, I'm going to give you an example. If you look at vector data, like I've mentioned, if you look at it, sorry, this one, move this side. Let's assume it's a house. Okay. On raster data, it's going to show the pixel qualities. Am I correct? It's that little blocks. We've discussed it. And let's assume this is our map. All divided up in pixels. And let's assume we got two isolated farmsteads over here with raster. There's one over there, and there's one over there. So as you can see, with the pixel quality, so these 2 pixels will represent your house. Okay, but with vector, it will just be 2 points. Okay, I'm going to give you another example. For instance, we use it. Let's just quickly have a look at points and lines. Now, for instance, if it was a river, and to represent the vector data, it will be a line, like I've mentioned. But with your raster data, once again, we're going to look at our pixel qualities. Unfortunately, we just don't have the examples here on question papers. So this takes a little bit of time. As you can see, that river will be a line on vector data, but on raster data, it will be the pixels showing, representing the river. Okay, remember, raster represents the pixels, the images, that little blocks when you zoom into your camera. Okay, when we look at vector, points, lines, or areas being represented on map. Now, once we get information, now we've collected, what did we do? We look at spatial data, we look at attribute data, we looked at how we collect it, we look at remote sensing, first of all, satellite images, photographs, take it, high resolution, low resolution. We got that information. People collected the data, right? And then we used spatial attribute data that the people collected the attribute data. They went and looked at stats. They looked at characteristics. Okay. They collected, they analyzed the information that's been given to you about certain areas. And then what do we do with all that information? We combine it. And that's with our next topic that we're going to discuss, and it's known as data layering. When we look at data layering, I just want to use a different color pen. Okay, what's the definition of it? It's all spatial data, whether it's vector data or raster data. That's shown in layers. Oops. Just want to get my pen back. Each layer presents a single entity. So if we look at data layering, it's all spatial data, whether it's vector data or raster data shown in different layers. Single entity. Now, if I can give you a quick example. Let's assume, first of all, where the studio are, right? What's our first topography? Okay, what type of soil do we find below? Then our next layer might be raster data showing us sewage supply, water supply. Where do we get our water from? So that's going to be the next layer. First layer is the topography. The next one is sewage, water provision. Then our next layer might be transport networks. Okay. And then the next layer might consist of property. Okay. Sizes, stands. This studio, for instance, how big of a size that we need to build this on, the type of land that's available. Okay. Then we can go even further with the next level. the type of climate that we experience. Obviously, it's not going to impact as much, but what type of climate, especially for a farmer, keep in mind, when the farmer chooses to do data layering, what does he do? First of all, he looks at topography. What's the gradient like? Steep, gentle, because he needs to use machinery to be able to farm his crop. Secondly, he's going to look at water. Irrigation, for example. Where is he going to get his water from? Thirdly, he's going to look at rainfall, for example, the rainfall area. Then he might look at transport networks because his goods might be perishable goods, because he needs to go and deliver his goods to the market, where a central place town. How close is he going to be to the central place town? So this is all your different layers stacked on top of one another. So like I said, all spatial data, whether it's vector data or raster data shown in layers, each layer represents a single entity. It is, we can add this, its characteristics that enables GIS solve problems. Enables GIS. Rather than not solve problems. Everything is not always a problem. So what do? GIS to manipulate, integrate, so with all these characteristics that we've mentioned, basically add them all together, and it gives us a better, not only because of problems, forget about problems. How can we make things better? Plan better for advance. Okay. Time is up. Thank you so much for this lesson. Really enjoyed it. Yes, all of us going to have an interesting week laying ahead. I'm going back to school. I hope you guys as well. But yes, it's interesting times. We do not know what to expect. I'm just asking you to be safe. And listen, it doesn't stop here, right? It needs to start at home as well. You need to put in the effort. We don't know what's going to happen. I mean, we are fortunate enough for Liberty to give us this time and give us this opportunity and Tenfold education. But yes, like I said, it's going to be a very interesting week. Look after yourself. You know, just practice with social distancing thing. Yes, it's going to be an interesting week. Hopefully, I do see you next week. I believe we're going to continue. And yes, looking forward to it. And all the best and be safe, guys. Cheers.